Hello, everyone. This is Ms. Pneumatic here. Today's topic is a hydraulic system. We're going to learn about what the hydraulic system is, the key components and operating principles required to operate the system, as well as its pros and cons and the field it can be applied to. What is the hydraulic system? It is a system that uses fluid energy made by compressing hydraulic oil to generate power and control machines and devices, such as a hydraulic cylinder and hydraulic motor. It is characterized by the use of pressurized oil as its working fluid. It can amplify a small force by dozens of times and turn it into a great force depending on the use and application method of this force. Heavy equipment, including excavators, cranes, and trucks, are typical machines that use hydraulic systems. Using the hydraulic system helps lift up or move a load easily and safely, which can be controlled precisely as well. Let me go through the units consisting of the hydraulic system. The hydraulic system can largely be divided into three parts: a hydraulic generator, hydraulic controller, and hydraulic drive unit. Let's begin with the hydraulic generator. A hydraulic generator comprises an oil tank, electric motor, and hydraulic pump. An oil tank is a storage tank where hydraulic oil is kept. This tank not only stores oil, but also cools off the high-temperature hydraulic oil through heat dissipation and removes air bubbles and foreign matters generated by circulation. An electric motor, or an engine, is a device required to operate a hydraulic pump. Connected to a hydraulic pump, it delivers mechanical energy to it. A hydraulic pump is what converts mechanical energy supplied by an electric motor into fluid energy through hydraulic oil. A small vacuum is generated at the pump inlet to soak up hydraulic oil from the oil tank, while generating high-pressure oil using the rotational motion of the internal components. Next is the hydraulic controller. Hydraulic controller is where the direction of flow, speed, and pressure of the high-pressure oil generated from the hydraulic generator is being controlled before it reaches the actuator. It consists of relief valve, directional control valve, and flow control valve. The relief valve adjusts the pressure of the fluid generated by the pump to the set value. The directional control valve adjusts the flow direction of the fluid to change the operational direction of the actuator. The flow control valve regulates the flow rate supplied to the actuator to adjust the operating speed of the actuator. Last but not least, let's see the hydraulic drive unit. The hydraulic drive unit converts the fluid energy into mechanical energy. This section is where the actual operation takes place through the high-pressure oil. A hydraulic cylinder and a hydraulic motor can be found here as a driving device. Among them, the hydraulic cylinder, which is most commonly used, carries out various tasks such as pushing, pulling, and moving objects through a linear and reciprocating motion. So far, we've looked over the components of the hydraulic system one by one. Other than the main devices, there are peripheral devices, such as filters that remove impurities from working fluids, and manometers for pressure measurement. Moving on, let's now find out how these devices work sequentially. First, the hydraulic pump soaks up the hydraulic oil inside the oil tank. At this point, an electric motor connected to the hydraulic pump continuously transmits mechanical energy to the pump through reciprocating motions. This is what causes the internal gears of the hydraulic pump to perform rotational motions, producing high-pressure oil. This is where mechanical energy turns into fluid energy. Then, the high-pressure oil moves to the pressure directional control valve to control pressure and direction. The pressurized oil controlled this way flows through the flow control valve into the actuator, activating the actuator. Various tasks will be performed depending on the functions of the actuator through reciprocating linear motion, hydraulic cylinder, or through rotational motion, hydraulic motor. This is where the fluid energy is converted back to the mechanical energy. The hydraulic oil that has been complete with the process will return to the oil tank through the valve. Then, the hydraulic oil in the oil tank is being soaked back up to the hydraulic pump to become high-pressure oil. These processes are repeated to allow the actuator to operate repeatedly. This is how we can generate and control large mechanical energy with only a small amount of force through the system process using hydraulic oil. Then, what are the characteristics of the hydraulic system? Let me summarize the pros and cons of the hydraulic system. Let's start with the advantages. First, it converts a small force into a larger force. Second, automatic and remote control is available. Remote control prevents machine operators from being exposed to hazards such as dust, rocks, debris, and smoke during work. Third, it is easy to control speed, force, and direction. Fourth, the lubrication and anti-corrosion of the system devices takes place automatically. This is because the oil circulates to automatically perform lubrication and anti-corrosive actions on the system devices, thereby effectively reducing wear and corrosion problems. Fifth, stable and precise control can be achieved. As liquid is used as working fluid, it is less compressible than the pneumatic system that uses gas as working fluid. Less compressibility also decreases fluid pressure variability, ensuring more precise control. Disadvantages of the hydraulic system are as follows. First, it is vulnerable to temperature changes. Viscosity decreased due to temperature changes may affect unit operation and cause actuator output to fluctuate. Secondly, there is a risk of leakage. Third, there is a risk of ignition. The working fluid is oil in the first place, so operators must take caution and prevent the oil from being ignited. Fourth, air bubbles mixed with oil may cause poor operation. Oil circulation may form small bubbles, and failure to remove such bubbles properly may result in poor operation of the actuator. Lastly, let's talk about how the hydraulic system can be applied. The hydraulic system is applied to a wide range of industries since it can be amplified to a larger force with only a small amount of force, and safe yet precise control is available. Typically, it is used when the linear motion or rotational motion of a machine or a greater force is necessary. As I mentioned earlier, it is applicable to all types of industrial environments, from construction and transportation systems such as excavators, trucks, cranes, bulldozers, special-purpose vehicles, and lifts. Machine tools such as CNC lathe, milling machine, drilling machine, transfer machine, and grinding machine. Steel and metal machinery such as forging, casting, and cutting. And robotics such as robots, rockets, and a whole lot more. Today, we took a closer look at the hydraulic system. Its process may seem similar to the pneumatic system. However, the working fluids are different, making it slightly vary in terms of the characteristics, applications, and devices. If you would like to learn more about the difference between the pneumatic system and the hydraulic system, click on the top 6 differences between the pneumatic system and the hydraulic system featured above. If you enjoyed today's video, please subscribe to our channel and give a thumbs up. I'll see you in the next video. Bye! Ms. Pneumatic Channel is working together with KCC Precision.